We are now on chapter 2, wherein we will discuss the determinants. Let us know the basic concepts of the determinant of a matrix. So for a 2 by 2 matrix, the determinant is defined as, so given this 2 by 2 matrix, its determinant is the product of the entries A11 and A22 minus the product of the entries A sub 21 times A sub 12. Or simply, the determinant is the difference of the products of the two diagonals. But take note of the order of the products. So you multiply this first minus the product of these two entries. By the way, we denote the matrix by this. We have the determinant of A, or we have this symbol. Example, so find the determinant of this matrix A. We have, so the determinant of A, you have this one. So we multiply these two entries and then minus the product of these two. So the determinant of A is equal to 7. We note that the determinant of a matrix can be positive, 0, or negative. Also, the determinant of a matrix of order 1 is defined simply as the entry of the matrix. For instance, given this matrix A containing only the entry -2, then its determinant is -2. Next, for square matrices of order higher than 2, we will use the cofactors expansion or cofactor expansion. We have here the definition for minor and cofactor. So if A is a square matrix, then the minor M sub ij of the element A sub ij is the determinant of the matrix obtained by deleting the ith row and jth column of A. And the cofactor Cij is given by C sub ij equals -1 raised to the I plus j times the minor M sub ij. For example, if A is a 3 by 3 matrix, then the minor of A sub 21 is this. So we delete row 2 and column 1 of the matrix and get the determinant of the matrix containing the remaining entries. So take note that when we say A sub 21, it means that this is the entry found on the second row and first column of the given matrix. That is why what we do is we delete the second row and the first column of the given matrix. And then we have here the remaining entries. We get the determinant of that. So that is now the minor M sub 21. And the corresponding cofactor C sub 21 is equal to, we have -1 raised to 2 plus 1. So this is the I and the j. And then times the minor M sub 21. So since this is 3, which is odd, then -1 becomes -1, or -1 raised to 3 equals -1. So we have here C sub 21 is equal to the negative of the minor M sub 21. Another example is the minor of A sub 22. So again, this means that we are on second row and second column. So we delete row 2 rather. We have row 2 and column 2 of the given matrix. And then we get the determinant of the remaining entries, or the matrix containing these entries. So therefore, M sub 22 is equal to the determinant of this. Also, its corresponding cofactor is this. So since we have an exponent, we have 2 plus 2, which is 4. So this becomes positive. So C sub 2, 2 is just equal to M sub 2, 2. Next, we have here the sign pattern for cofactors. So if, for example, we have a 3 by 3 matrix, then the cofactor of A sub 1, 1 is just the minor M sub 1, 1. The cofactor of A sub 1, 2 is the negative of minor M sub 1, 2. And the cofactor of A sub 1, 3 is the minor of M sub 1, 3, and so on. If, for example, we have a 4 by 4 matrix and say we need to get the cofactor of A sub 3, 2, so we have the third row and second column, so we have this. Since we have a negative here, then the cofactor C sub 3, 2 is the negative of minor M sub 3, 2. Note that odd positions where I plus j is odd have negative signs, and even positions where I plus j is even have positive signs. Now let us have an example of finding the minors and cofactors of a given matrix. So given, we have here matrix A, find all the minors and cofactors. So first, we find minor M sub 1, 1. To do this, we need to find the determinant of the matrix after deleting row 1 and column 1 of the given matrix. That is, we will get the determinant of this. So the remaining entries we have here, we copied it here. And since this is just a 2 by 2 matrix, we get the determinant by getting the difference of the product of these two entries and the product of these two entries. So we have, negative 1 times 1 minus 0 times 2, so that is equal to negative 1. Next, we find the minor M sub 1, 2. So this time, we will delete the row 1 and column 2. So we get the determinant of this matrix. So we have that. So again, we get the determinant by multiplying these two entries minus the product of these two. So we have 3 times 1 minus 4 times 2. So that is equal to negative 5. So you do the same for the rest of the entries. So I have here all the minors of the matrix A. Now for the cofactors, we can follow the sign pattern given just a while ago, wherein we have the first, the positive of M sub 1, 1, next the negative of M sub 1, 2, and then the positive of M sub 1, 3, negative of M sub 2, 1, and so on. So we have the following cofactors. Next, so this time we will use the cofactor expansion in finding the determinant of a matrix. So we have a definition. Let A be a square matrix of order n. Then the determinant of A is given by, we have the sum of A sub I1 times C sub I1, then plus A sub I2 times C sub I2 plus and so on until A sub IN times C sub IN. So this is called as the ith row expansion, or the determinant of A is equal to the sum of this. We have A sub 1j plus times C sub 1j plus A sub 2j times C sub 2j plus and so on up to A sub nj times C sub nj. So this is called as the jth column expansion. To illustrate this, we have given a matrix A. Let us find its determinant. This is actually the matrix given in the previous example where we got the following cofactors. So by the definition of a determinant, we have the determinant of A is equal to A sub 1, 1, C sub 1, 1, plus A sub 1, 2 times C sub 1, 2, plus A sub 1, 3, C sub 1, 3. We have a 3 by 3 matrix. So this is by first row expansion. So this is equal to 0. And our C sub 1, 1, the cofactor C sub 1, 1 is negative 1. Plus A sub 1, 2 is 2. And then C sub 1, 2 is 5. Plus we have 1 times 4. So this is equal to 0 plus 10 plus 4, which is equal to 14. Note that we can find the determinant by expanding any row or column. So for instance, in this same example, instead of expanding the first row, we can expand, say, the second row so that we have determinant of A equals A21, C21 plus A22, C22 plus A23 times C sub 23. Okay, so this is the second row expansion. So this is 3 times negative 2, negative 1 times negative 4, plus 2 times 8. Okay, so this is equal to negative 6 plus 4, then plus 16. So this is equal to 14. So we got the same answer. Or you may also choose to evaluate by expanding the third column. So that is, we have the second part of the definition. So the determinant of A is A sub 1, 3 times C sub 1, 3. So this time we are expanding a column, third column expansion. So A23, C23 plus A32, 32, 33. Sorry, this should be A33 and so this is equal to 1 times 4 plus 2 times 8 plus 1 times negative 6. So this is 4 plus 16 minus 6, so that is equal to 14. So in finding the determinant, you actually don't need to solve all the minors and cofactors. You just have to choose which row or column you are going to do the expansion. Also, note that when expanding by cofactors, you do not need to evaluate the cofactors of zero in entries because a zero entry times its cofactor is just 0. So, the row or column or the row or column containing the most zeros is usually the best choice for expansion by cofactors. So for example, find the determinant of matrix A. Again, the best choice for expansion is the row or column with most zeros. And in this case, we have column 3. So column 3 has 3 zeros. So we will do the third column expansion. So we have A sub 1, 3, and then A sub 2, 3, A sub 3, 3, and then A sub 4, 3. And since these entries here are 0, we only need to get the cofactor C sub 1, 3, so corresponding to this entry. We have C sub 1, 3, the cofactor C1, 3 equals -1. We have the first row plus 3, which means the third column, multiplied by the minor m sub 1, 3. Since the exponent here is 4, which is even, so this is +1, so this is just equal to the minor m sub 1, 3, which is, we delete the first row and the third column. So the remaining entries we have, so that is -1, 1, 2, 0, 2, 3, and 3, 4, -2. Now we have to get the determinant of a 3 by 3 matrix. This time, we may choose to do the first column expansion. So we have a 0 here. So that is our C1, 3 cofactor is equal to, we have -1. Again, we will do the first column expansion. So we will use these entries. So this corresponds to A sub 1, 1. So that is -1. So this is A sub 1, 1, -1. And then we have first row and second column times the determinant of, so we delete this row and this column. So what we have is 2, 3, 4, -2. So we have that matrix. And then plus we have the second entry. We have 0 and then -1 times. This corresponds to the second row and first column. So that is 2 plus 1. And then we delete this. We have that. So the remaining entries, we have 1, 2, 4, -2. And then plus we have A 3, 1. So that's 3. So we have this A sub 3, 1. So that is times -1 times 3 plus 1. And then multiplied by, we delete this row and this column. So the remaining entries, we have this 1, 2, 2, 3. Okay, so we compute this. This is equal to, this becomes positive. So we have negative times 2, 3, 4, -2 plus, so this just becomes 0. Actually, we don't have to compute for the cofactor here. You can just skip this part. Plus, this is 4, so this becomes +1. So we have +3, 1, 2, 2, 3. Okay, so we need to compute now the 2 by 2 matrices, these matrices. So we apply we have here, we multiply this and then minus the product of these two. So this is now 2 times -2 minus 4 times 3, then plus 3 times, we multiply again this diagonal minus the product of this. So we have 1, 3 minus 2 times 2. We simplify, we have here, this is -4 minus 12, that's -16 plus 3 times, this is 3 minus 4, so that's -1, which is now equal to, this becomes +16 here, minus 3, so that is 13. So we have that, or you may choose to expand to, or to do the second row expansion. So since the determinant of A is equal to 3 times the cofactor C sub 1, 3, which is 13, so we get the determinant of A equals 39. Next, we will introduce now an alternative method in finding the determinant of a 3 by 3 matrix. Copy the first and second columns of A to form fourth and fifth columns. And then the determinant of A is obtained by adding or subtracting the products of the 6 diagonals as shown below. So again, we simply copy these two columns, column 1 and then column 2 to have the fourth and the fifth columns. And then we multiply the diagonals. We have this and we have this diagonals. So the determinant of A is given as A sub 1, 1 times A sub 2, 2 times A sub 3, 3. And then plus the product of this 3 plus the product of this 3. And then minus the product of this, the product of the minus the product of this, and then the product of this. So to illustrate this, we have an example. So find the determinant of matrix A. What we do is we will copy the first and second columns to obtain the fourth and fifth columns. We have here 0, 2, 1, 3, negative 1, 2, then 4, negative 4, 1. So we copy these two columns. So 0, 3, 4, 2, negative 1, negative 4. So you do the multiplication of the diagonals. Start from here. And then we subtract the products of this. Okay, so that is the determinant of A is equal to product of this. So that's 0. Is 0 times negative 1 times 1. Then plus the product of this. So we have 2, 2, 4. Then the product of this diagonal. We have 1, 3, negative 4. And then when we move to this direction, we subtract. So this is minus 4 times negative 1 times 1 minus the product of this diagonal. We have negative 4 times 2 times 0 minus product of the last diagonal. We have 1, 3, 2. So we have this becomes 0. Then we have 16. We have negative 12. The product of this, we have positive 4. The product of this, we have 0. And then the last one, minus 6. So this is equal to 4 plus 4. So that's 8 minus 6. So that is, the determinant is. Next, we have a theorem. If A is a triangular matrix of order n, then its determinant is the product of the entries on the main diagonal. That is, so determinant of A is the product A sub 1, 1 times A sub 2, 2 times A sub 3, 3, and so on up to A sub nn. For example, find the determinant of this matrix. So notice that this is a triangular matrix, a lower triangular matrix. Then to get its determinant, we simply multiply the entries on the main diagonal. So we have 2 times negative 2 times 1 times 3, which is equal to negative 12. Another example, we have matrix B, which is again a triangular matrix. So its determinant is the product of the entries on the main diagonal. So that is negative 1 times 3 times 2 times 4 times negative 2, which is equal to 48. So the proof of this theorem is left as an exercise. We will continue the discussion of with determinant in our next video.